Okay, so microphone seems to be moving, right? All right, so I'm going to go ahead now and share the screen again, guys, if you can pay attention. All right, so I'm sharing the screen. I believe we are recording. So we're going to continue with our example. So if you remember, we were just grabbing a batch of images. I did for 3, but you can hopefully see that that would apply to any number of images. Later on, as we progress in the next few weeks, we will take a look at a data set very much like MNIST, but much better, okay? Where we actually have 70,000 images and we're going to process them and so on. And it'll be something similar to this. So now, as I said, what you need to be doing right now in these days is just practice these things that I've given you so that you understand them really well, all right? Because later on, we're going to, you know, we're just always going to use these building blocks. Okay, so we had the batch created. And then now there's a couple of things that we can do to the batch. One thing that you always should do to your data is something called normalization. Okay, you're going to normalize your data. And what that means is that your data might be in different ranges, right? So the data might be in a range from, let's say, 0 to 1,000 or 0 to 2.3 or, you know, different ranges. We always want to normalize things to either an area between 0 and 1, right? A range, sorry, between 0 and 1, or even where we normalize things to the mean of the data, right? With a specific standard deviation, okay? So that's called, you know, 0 mean and some standard deviation, and all values are going to be converted to that. It's a mapping function called normalization. All right. Usually we're just going to use, you know, some technique to do it. So here I'm going to give you one of the techniques. You don't have to worry so much about this right now. What I do suggest is go practice it. But as I said, we're normalizing the data. So, and it is always recommended for any kind of data to normalize it. So remember, you know, make a note in your notebook, right, that you should always normalize the data once you have it. So there's a couple of ways. And we might, once we look at the lectures and everything, we might take a look at the equations. But for now, let's just do an exercise here. So I'm going to put it under normalize the batch. All right. And so what's going to happen here is I'm going to create the thing that we need to normalize is the information that in the height and the width cell, right? That's really what, you know, because we have an R and a G and a B, right? Red, green, RGB, and blue. So we have the individual ones. Each one of those has pixel values, right? From 0 to 255, for instance, which, you know, are the scale, right? And it gives you the different shades of the color. So we need to grab each one of those, the R, the G, and the B, right? And just normalize those values inside into a different scale. Okay, and so that's what we're going to do here. So first thing I'm going to do is I'm going to take the batch and I'm going to convert it. So I'm going to do batch dot float. Okay, notice that Torch has this ability that sometimes you can just, you know, grab something, call a function, and produce a new output, right? So we have that. So basically that just means that we made everything into float values, you know, real, decimal. We also want the number of channels here because that's really upon, you know, the data that we're going to convert. So I'm going to do n channels, and I'm going to grab the batch, and that we know that's shape 1 in the batch because the first one is the batch number, second one is the number of channels. So that's 1. So if we print this one, it should be 3. You should always corroborate. So I'm going to run it. And you can see that's 3 right there. So I've got the value. Okay. Now, once we have I can take this out really. And now once I have the number of channels, I'm going to then sort of create a loop. So I'm going to do this for every single one of the red, the blue, and the green. So those values for, in red, blue, and green are going to be changed from the range of 0 to 255 to a new range, right? Considering what is the mean of the data and the standard deviation of the data. Right, and so I'm going to do here for C in range. And then, of course, the range is going to be just n channels because I'm, again, just grabbing first red, then blue, then green, colon, right? And then 1, 2, 3, 4. And so now I calculate the mean, right? The average, if you will, of all the values. So I'm going to say torch. Oops. I'm going to say torch.mean. And I'm going to say here, I take the batch. Okay. And I'm going to take out of all the batches that dimension, red. You guys see that? So this is a type of slicing. So these things don't come so easily sometimes to us. But if you think, batch has 3 batches, 3 channels, and height width, right? It has that. So if you look, we just say out of all the batches, because all batches have a red, yes? All batches have a green. All batches have a blue, right? So basically we're grabbing where these are the amazing things that you can do with these things. Imagine before you knew this, how many for loops and iterations you had to do to get this data. Very inefficient to do that. Here, we just slice it out. And so here, whether it's 3 or 70,000, we can do it. You see? So this is just an example. Really, that's what this is meant to do, because there's actually functions that you plug in, say normalize, and it gives you the output. So that might be an easier thing later on. But for this case, just to illustrate, this is pretty useful. So basically, I'm using torch mean. I grab from batch all the samples, images, and I grab the specific channel that I want, because I'm iterating from 0 to 3, right? So the 3 channels that I got, so I'm going to get 0, 1, and 2, every iteration. So then I've got this one, that's the mean. So out of all, I get the mean. Then I get the standard deviation. Okay, and then I'm going to get, and that's going to be torch. And then that's the same thing, right? So we just plug in batch here. Oops, sorry. We just plug in batch here. Trying to be consistent. Colon C. Yeah, like that. If you notice, they're exactly the same batch, or the same, this part is exactly the same. We just apply a different function. Let me do these. I always like these things to align. All right, you see that? So that basically, I'm calculating the mean and the standard deviation, right? And then I'm just going to apply that. Once I have them, there's like an equation basically. And I'm going to apply these to the equation, and I get the normalized version of the original data. Okay, I strongly suggest that you play with this example on your own. Okay, print out everything that's going on. Make sure right now it's kind of easy at the beginning because you don't have that much homework, but certainly go through these, okay? And get a good command of it as we start doing problems. Because I still need to show you how to read the data, then how to do the models, and then we'll have homework. And then finally, once I have these, I'm just gonna apply the formula. So for each batch, notice here, I'm gonna do batch, just the same as the other ones. So for all, and for that particular channel, whether red, blue, or green, right, I'm going to take it, and then I'm going to apply the formula. And the formula just takes the original value, so batch, you know, like this, right? If you notice, that's the same as this one, which is the same as these two top ones. And once I have it in the parentheses, I just subtract the mean from it. So it's going to be mean, and then this is divided by the standard deviation. And that's a normalizing function that's out there, basically. Okay, so it's almost like x minus mean divided by standard deviation. Okay, so that's what we did. So play with this one, but that should do the normalization, and that is always really important. And in particular, because just keep in mind that deep learning does better when things are normalized. That's kind of the, if anything, the intuition that you always have to remember. It's like a slogan, you know, deep learning always learns way much better when things are normalized. Therefore, I must always normalize my data, right? And this is just one example of one of the ways that you can normalize. You can do it the equations way, or you can do it like a function way. There's a lot of functions for this as well. So we'll just see multiple examples. All right. And as you can see, so I've done this now. And that gives me now a normalized version of the data. So now I can go ahead and print batch again. I think we were printing it before, I believe. So we take a look at batch. Let's go ahead and then let's add a new line here. Okay, so control X, Y. Hopefully it won't give an error. All right, so if we look, let me actually print it twice just to make sure. Yeah, we were printing it. So you see the difference, hopefully. So we go back to the code, you see that these values kind of go from like -1 or -2, let's say, to +2. You guys see that? They have been mean centered, basically. Okay, does that make sense? And that's important because you might have data that's in the range from 0 to 200,000, right? Like housing prices, you know, a house costs what? 300,000, you know, whatever, right? On average, here in California, it's like 700,000 for something small. And so that's a wide range. Imagine if you're in the, your what's that company? Zillow, right? And you got all these ranges in California and New York, here. And so then you do those values and you build a model. Now, if you decide to normalize all that data, now none of the values are going to be 300,000 or 200,000 or 700,000. They're going to be like this in a range from -2, let's say -1.5 to 1.5. And actually, you can expect your model to do a lot better. It's been proven like experimentally over and over and over and over again. Right? Deep learning does really well with that kind of data. Does that make sense, guys? It's a very important thing that I always tell students, you know, if they say it's not doing well, did you normalize? Did you normalize? Okay. All right. So we've done that part. Now let's do another thing. Just kind of we're not really using this yet, but I've found over the years that the best way with this is just to show it every now and then, right? And then you're aware that it exists, and there will come a time when you need exactly this function, okay? The unsqueeze function and broadcasting we haven't covered, but it's a little bit more complex. We'll cover it at some point. So let's do another, I know we did a lot of unsqueezed examples last week, but just because we have a very complex batch here, it kind of makes sense to play with it a little bit. Let me just check the video again. So the audio seems to be moving, okay? So let's go over here. And we did the normalization, right? So we completed normalization. Now let's go and do unsqueeze again. And again, just keep this in your toolbox. So this is going to be unsqueeze. And what is this unsqueeze? Unsqueeze is adding a dimension here and there. And that's usually helpful whenever you're multiplying tensors. There's going to be situations where you need to do certain very efficient operations, right? That actually, if you just did an unsqueeze and add a dimension and do this multiplication, you get what you want, okay, out of the whole data set, right? And so for now, as I said, this happens like when you're using very complex algorithms like transformers, which are like the most complex deep learning algorithm that I've seen, at least. It's pretty complex, but very powerful. And so when you use these kinds of operations. So what is it? So let's take a look at, since we have this batch that's pretty big right now with a lot of dimensions, let's use unsqueeze again. So what am I going to do? I'm going to take out the batch shape. Okay, that's without the unsqueeze. Now I'm going to add batch new, right? And I'm going to do torch dot unsqueeze. Just making sure I got the spelling correct. And then I'm going to do the original batch. And here I'm going to change this value in a couple of iterations. I'm going to do 0, 1, 2, 3. And I just want you guys to notice the difference. So if I do print, and I'm going to do batch underscore new, batch shape, and you'll see what I'm talking about. So I do Control X, Y. Oops, sorry. So what do you notice? Look at the dimensions. So the batch is 3 by 3 by 256 by 256. I did unsqueeze 0, and it added a new dimension 1, 3, 3, 3, 2, 5, 256, 256. You see that? As I said, this is something that's not so obvious right now, but just be aware of it. In more advanced algorithms, this is actually very helpful. So let's change it to another value. So instead of 0, let's do 1. And you'll see the effect. It grabs a dimension, it adds in a dimension somewhere else. So now 1. And look at how now it put the dimension between the two 3s. So now there's a dimension in there. And this might be when you know that, like we did with the the RGB, right? You know that you kind of you have this huge tensor, right? Which might be images of timestamps of this and this and that. But you just need to be efficient to apply an operation, a transformation, just to the RGB part, right? And so you create a tensor of a specific dimension, and you just need to add a 1, somewhere in there so that you can make the multiplication correctly, right? It's more of a dimensions thing, okay? As I said, in this class, we probably won't encounter anything that complex because that's more of the next class, deep learning, where we look at transformers. That's where you might see something like this, but still I like to just, kind of put this in your mind, right? This power of, the other one is broadcasting, but we'll cover that later. All right, so that's basically it. Images are kind of the biggest batch that we're gonna get, right? Because we have height, width, we got RGB, so it kind of makes sense to play with it like this. Now, I would argue, you know how to load your images. Would you agree that you know how to load images now? I would say so, right? We did it for 3. I may have, in the homework now, I could probably say, here is what is it? MNIST. What would you have to change? Instead of 3 for channel, it would be what? If it's black and white instead of color. 1. There's only 1. So the RGB is color, 3. Black and white is just 1. Okay, that's it. So I could give you MNIST, which has train set, sorry, that has 70,000 samples, right? Training and testing, but not, and you have it as a folder, so you could read it in. Later on, I'll give you another data set also with color images, 70,000 or so. You can read it into a batch of some kind. 70,000 should fit in these computers. In one shot, you should be able to get 70,000 into a batch. Although it's not recommended, it'll probably work. Okay? Any questions? All right, so we covered this. So the next thing, so far, this is good enough for images. I think it gives you kind of a clear picture. We'll do another more involved example with images later on, probably. But now I want to switch over to another type of data, okay? So the next type of data, we've looked at images. Yeah, so the next type of data is we're going to read CSV. So let's go ahead and do that. So let me clear. And for this, let's go to, the file system. Actually here, there. And let's go to data. Now the next file of interest will be this one, wine quality. Apparently it's white wine, and it's a CSV file. So I'm gonna hit this one over here. I'm gonna open gedit. That should be an editor that I can use for this. Ah, there we go. You guys see that? What do you see? What's CSV, first of all? This is a text file, right? First of all, that's a text file. What does CSV stand for? Comma separated file. Comma separated file is your best friend, right? And a lot of the time, I always revert back to comma separated files for everything, right? Because even though later on I might have a huge data set, like a huge data set, when I'm developing the original code, I just grab a subset of it, right? Something that I can manage in the computer, play with, get a feel for, and then after that, might say, okay, this thing is ready. I'm going to run it on my GPU box or something like that. But usually I just like to, try things out on my laptop first, on a couch or somewhere. So anyway, so CSV is your best friend, right? So you just grab the text file. So how does it work? So a CSV file, it's got rows and columns, usually separated by comma. That's where the CSV comes in. However, if you notice, this one is actually separated by semicolon. So it's always good not to assume, right? Don't assume your data. Remember, data science, a lot of the work is just looking at this data. Because, if you think about it, you'll have a lot of algorithms. If you just go to my GitHub, every single algorithm is there. There's some code there. You can just grab it, feed your data into it, right? But getting the data into the format that goes into these algorithms is always very challenging, right? Or can be challenging. And so this one's a very useful one. So if you notice, the first row is basically the variables, all right? So in this case, what are we doing? We're saying wine quality. So we have a data set about the quality of wines, white wines, according to some person, right? According to somebody. So if we look at the last variable, it is actually called quality. It's probably a score. So if I look here, it's a 6, 5, 7, 8. So humans, right? Humans came in and scored the wine. Probably professional wine people. They came in, looked at this, scored it. That's called the dependent variable, right? The dependent variable, because the idea is that when you build a model, what are you going to try to do? You build a model to predict this quality automatically, given some factors that you can measure. So what are these factors? Usually the previous column. So in this case, fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, the pH balance, sulfates, and the alcohol content. All of those have been quantified here. So every row, this row just represents for one wine, I'm sure, because we know this is ID 0, then ID 1. So there's probably somewhere where they have ID 0, oh, it's wine so-and-so, and so on. So all these are Portuguese wines according to the description here. So, you know, they have names, I'm sure, Portuguese. So anyway, if you notice, they're separated by semicolon, which means that 7 is fixed acidity for the first row here. 7 is fixed acidity. 0.27 is volatile acidity. 0.36 is citric acid. Alcohol content, 8.8 or something like that, right? And so this is your data. You're gonna build, if you were gonna build a model, all those variables would be the independent variables. And the quality is the dependent variable because it's dependent on those, right? So since you're gonna build some kind of a model. So in this case, all we're gonna try to do is load this data into Torch, right? And that way, you know, as I said, we're not building any models today, but I'm just showing you how to get the data into the tensors. And then, of course, we're gonna start doing that. Any questions on this one? Make sense? All right, so this CSV is already in the data folder. So all we have to do then is open up our terminal again. I'm gonna continue using read data to PyTorch, but now I'm gonna add a new section that is no longer images. Okay, this is going to be reading a CSV and loading into tensors. So I'm going to do here, read CSV, right? Read CSV. And it's going to be the white wine, Portugal, let's say. Okay. So what do we need for this one? A library, import CSV. If it tells us that it's not installed, we're going to have to install it, or it could be a default library of Python itself. So once we have this, we're going to specify the path where it's located. So I'm going to say wine path, and this is going to be equal to data, right? Because it's in data. Wine quality white dot CSV, like that. So I've got the path name to the wine itself, and now I'm going to load it. So I'm going to do wine q underscore numpy, and here I'm going to introduce yet another very handy function. Okay, so numpy, NP, I actually like to use this one quite a lot. So numpy has a function called load txt. Okay, and it's meant basically designed kind of to read CSVs. So I'm going to say over here, I'm going to say here the things that I need. So I need the path, so wine path. Okay, I got that one. I'm going to say that I want the data to be represented as data type is np.float 32. All right, so they're going to be float values now. The delimiter is going to be not a comma, but a semicolon, as you saw in the text file. And we're going to say skip rows. And which one do we skip? We skip the first row. Notice here it doesn't start at 0, okay? So sometimes there's inconsistencies like that. What does that mean? It means that the header file, the one that had the words quality and all that, gets ignored. Because remember that when you load something into a tensor, it only takes numbers. Okay, those words would confuse it and it wouldn't understand what's going on. So we just, it's useful for us, and you have to always make sure that you know the order of the columns to match it back to this. So in this case, I know one thing. I know the last column is the quality. Therefore, that is the value that you're going to predict. And the rest are the other variables, the independent variables. So that's pretty nice because now we can load the file. Notice it loads it by default as a NumPy array. Okay, so we're gonna go ahead now. Once we've loaded it, we probably want to print it out. So I'm gonna do print. And I'm gonna do wine. Oops, sorry. I'm gonna do wine q numpy. All right, so I've got that one. I'm also going to do the shape. I always, get in. You'll see that you'll get into this habit fairly quickly. So you'll do wine q underscore numpy dot shape. Okay. And so let's just currently it's a numpy array. We probably want to make it into a torch thing, but for now let's process it like this. Right? Run it, and there you go. So what can you tell me about it? How many samples? 4898, 4,898. How many features? 12. Features mean remember, we're going to start to get into the lingo here, and features just means the independent variables, right? The things that describe the sample. If I ask you how many samples, 4898. How many features? 12. You guys see that? Actually, I'm wrong. Not 12 features. 11, right? Because the last one is not a feature. It's actually the value you're trying to predict, the quality. You guys see that? All right. So now that we have the NumPy array, let's go ahead. So let's say you were going to build a model. You were going to build, a machine learning model, with PyTorch. So what's the next thing? Well, since we're using PyTorch, we need to convert it to a torch tensor. Okay, from NumPy. So I'm going to come over here and I'm going to say wine q is going to be equal to torch dot from underscore numpy, right? And I'm going to take in, here wine q numpy. Now I make it into a torch tensor. Now that's going to fit into my machine learning model. You'll see this is actually, it's really nice because once you figure out all these functions and you practice them a lot, and then we hit neural networks, you'll see it. You'll pick it up really quickly. Okay, there's gonna, we're gonna look at some things of how it works, but there's a basic scheme that you follow. There's a basic scheme, and if you learn that, it's going to be pretty easy to do multiple deep learning algorithms really quickly. Do I? Oh, I'm sorry. Yeah, you're right. Thank you. Right. So at this point, this converts it into a tensor. So now, as I said, you'll probably want to get into the habit of always printing things out, just so that you can see what's going on. So in this case, wine q is now a tensor. You want to maybe look at the shape. You might want to look at the type, the data type, I mean. So you might want to look at the data type. So it's going to be wine q dot data type, like that one. You see that? And so now let's proceed. Look at what it is there, right? Those are NumPy arrays at the bottom. Now they are, there's the data type, float 32, it's a torch. And notice the dimensions now basically implies it's torch, but it's still 4898 by 12. You see that hasn't changed. All right, these are just good ways of doing things. Now, we get into, I've been talking about this independent variable, dependent variable. Whenever you do machine learning, you actually want to always separate the dependent variables from the independent variables. It's always going to be two tensors, okay? So that's usually what is referred to as X and Y. Because if you remember the original equation, Y equals mx plus b. Always, remember that. That's your equation right there. In machine learning, right? So Y equal mx plus b. So the Y and currently the Y and the X are together in this line Q, right? We want to separate it out. And that's going to be the same for everything. Classification, linear regression, whatever it is, we're always going to separate it out. So again, we just play with the tensors. I'm going to go ahead here. I'm going to scroll all the way down. And I'm going to do, let's add a new line. And this is going to say get X. Usually X is uppercase. That's just going to indicate it's a matrix. And Y could be like this to indicate it's kind of a vector because it's just usually like a column vector. There's only one. There's one. It's something usually n by one. Whereas the X is n by m, right? The Y is always, n by m, so n by 1. Got it? All right. So we're going to get the X and the Y. How do we do that? Well, everything is in Y and Q, right? So we know that. So Y and Q has the data. Now I want the X data. So I need to slice out. We saw that it was what? 4098 by 11, correct? So what do? But they're both 4098. For the first parameter, when I slice, I'm just going to say colon. Colon just means all of them, all 4098. All right. But for the other values, I need a range, right? This time there's 12. I think there were 12. So I just need the first 11 minus the last one, right? So if I want to get values, so if I have a range of values, right? If I want to go from here to the end, I use positive numbers. But if I want to go from the end to the beginning, I use negative numbers. That's all it is. So what I'm going to do here is then, therefore, I'm going to say, you guys see that? What does that do? It tells me grab all the columns except the last one. Okay? And so that's a very handy way of doing things. Now I give this one, so that gets X. Let me call this data. What I'm going to do over here, I'm going to say this is X as a comment. Now, you guys tell me, for the target, line Q, right? And this is going to be comma because there's 2. And this, oops. Just be aware this is Y. All right, how do I slice just that last column of Y and Q? Say that again. Here, -1. Okay, good. Because not the range, but just the last one, right? Just colon at the beginning, exactly. Very good. Oops, sorry. Because I mean all of them, right? So I grab all 4098, but just the last column for target. For data, I grab all 4098 plus a range, because this implies a range from the first one up until excluding the last one. And always just test it out. You can always do a little example of your own data, test it out, and then if it works for the bigger one. Always double check your data. Now, remember that old saying in computing, right? Garbage in, garbage out. Doesn't matter how good your algorithm is if your data is terrible. Okay? So that's always, like in industry, for instance, you may have to produce really fast results, right? Your client is just like, we need to launch something on Thursday. Can you just, And you might do it, but you're not 100% sure if it's correct, right? So there's a lot of things that can go wrong. So check as much as possible. Is what I'm saying. All right. So is this clear, guys, so far? We separated out the data X and Y. We're not really building any models right now, but this is really important. Now we can look at, let's do this. Let's do data dot shape again to kind of confirm print target dot shape. All right, so we do both of these. Control X, Y. And you can see there. So we've got 498 by 11. This one is just 498. Sometimes this one, let's say that I want, for whatever reason, I really want that one. It's 4098 is correct, right? The last one, but I want it to be 4098 by 1. What do I do? Unsqueeze. Who said that? Very good. Unsqueeze. Perfect. You see, that was an example of unsqueeze. And so keep that, keep that as part of what we're doing. Any other questions, guys? Nope. All right, great. So this is, we saw how to, so at this point, you would say, okay, what do I do with that X and Y? Well, then now we would build a model because, the Y goes somewhere, the X goes somewhere. We need to divide that X and the Y into train and test because we would train the model, but then we validate it, that kind of thing. So that will be another set of things. But for now, for today, I just want to focus on reading in data and some of the data processing. Okay. All right. So now, let's take a look at. So that was, we can come back to this in a, later, but now let's take a look at the other one. Let's take a look at text. So if you remember, I've shown you examples of images. I showed you example of CSV data that's already very nicely formatted for you, right? And it was a text file, but the thing there is that it's formatted in a CSV format. Now, what I'm going to do is I'm going to show an example of what do you do with text, which is not formatted like the CSV is. It's a text file, but it's on what is called unstructured data. Basically, natural language processing. I believe the story is Jane Austen. So it's going to be like that. So we're going to grab that and see what we can do with it. So let's go ahead and let's do that one just so that you have for completion all the types of data possible. There's a couple of other things we can come back to later. So let me add a comment here, and I'm just going to say text. Okay. So so what do you do? So the first thing is I want to read the file. So I'm going to say with, and there are many ways of opening a file, but with open, and I'm going to say the file name is, it's in data, and it's 1342-0.txt. And that was the Jane Austen story, right? So I'm just gonna, you can get any story that you want from Gutenberg. It is encoded in what is called UTF-8, okay, like ASCII. So we just specify that here. This kind of thing you just have to do on your own. There's really no set of rules for it. There's a lot of options, basically. So UTF-8, and then we're going to say ASF, right? So that's our file handler. That's what that's called officially. And then now we're going to, now that we can kind of format the file, we're going to read it in. read the text in. I'm going to do 1, 2, 3, 4, and text, simple text f dot read. So as I said, there's a lot of problems that you will tackle like this. A couple of the homework examples I'm going to give you later on are download URLs, websites, and clean it, get rid of all the HTML, download, what is that? Those things? Feeds, I think they're called feeds. Download the feeds. I'll give you some examples, clean them, and then finally download Twitter data, clean it. All right, I think I gave you the metadata and also the text. Obviously, from Twitter, we can't really get, I think, hopefully it hasn't changed, more than 7 days worth of tweets, and very, very throttled, if you will, very limited, because obviously their business is selling that data. They sell it to companies that do marketing. There's a lot of business in that area, so that what they do is they buy from Twitter. But for our purposes, by the way, by at this point, even though I haven't assigned the homework, usually what happens is I assign it and then I have to delay it because you have to get a developer account in Twitter to get the data from Twitter. So actually, just so that I'm more efficient this time around, I'm going to say now, go ahead and go to Twitter. If you haven't done so already, get a Twitter account, and in particular, get a developer account so you can have access to the Twitter API, right? That usually takes a while. Just say that you're a student, you're taking a class in machine learning, you need it. There's usually no problem, okay? But it does take a while. They have to approve it or something. So the homework will come later, but just please do that so there's no delays later on, okay? It's good that I remember. So anyway, you would have the tweets, usually either URLs, feeds, RSS feeds, that's the word. RSS feeds, tweets, whatever they are, you download them to a text file, right? You download them so it's similar to this. Then this is a text file of Jane Austen, so you read the text. Now, what you can do with text is a lot, okay? I'm not really even gonna get into a lot of it. There's a lot of approaches, word to vec, word, embedding vectors. Those are topics for the deep learning class, okay? Not for this one. Specific things, bag of words approach, etc. All right, so we're just gonna, right now we're just gonna simplify things. But keep in mind that one thing that's really important in machine learning is that everything is saved as vectors, okay? And we'll talk a little bit, I'll do a lecture at some point on vectors, now that we're getting to the point where I think next time we meet on Tuesday, first hour, I'll probably do a lecture, because now there's a lot of topics on normalization, what is a vector, those kinds of things. So I'll go into some of that. But for now, I just want you to practice. Anyway, so we would technically grab the text on structure, convert it into numeric format, vectors, if you will, right? And so there's many algorithms for that. So let's just think of some of the, but for now, I'm just showing you the basics of how to get it. So here we have the text. So I'm just going to print it. I'm going to print my text here. It's going to be a lot, by the way. So it's pretty big. It's the whole book. See, there it is. That's the whole, Jane Austen book from the Gutenberg Library. So how do you process this, right? So, well, you have to think about how a text file stores data. So here, every line has what at the end? /n, right? /n, the \n. That is called a new line character. We don't see it, but it's there. And so what that means is that the new line character is actually separating out the sentences, right? So let's kind of use that to obtain the lines. So then I'm going to go ahead. Usually this is a common practice, at least in this class, we'll take this approach of just looking at all of these. All right, so now I have my text here, and I'm going to say lines equal text dot split. again, this is a lot of not Torch things, okay? This is more of a Python thing, so really the sky is the limit. If you know Python really well, I'm sure you have 1,000 ways of doing this, okay? So now I'm gonna do split. You know, I'm gonna split on new line character like that, and then I have my lines, and then I can, let's say, I'm not gonna print out all lines, but I could iterate through the lines, for line and lines, you know, that kind of thing. Maybe I'm just gonna slice out, you know, let's say temp lines, for instance, you know, something like that. So then I'm gonna do lines to 200, right? So the first, remember, this is a list in Python at this point, right? You guys agree that we're currently at a Python list, not a NumPy array, not a Torch tensor. And so we don't really need a Torch tensor just yet. And so I'm just gonna print this list, the first 200 or so. Let's see what it looks like. I'm gonna do print temp lines. All right, so let's go ahead. And did it work? No? No, it did work because let's I guess iterate through it. I'm sorry? Oh, just the line 200? You're right. Yes. Yep. You mean like that, correct? Yes, you're right. All right, thank you. So perfect. Good catch. That's right. So I was only getting the 200 sentence. This is actually what I was looking for. So I can see here, there's probably a couple of enters in there that are just white space. But if you see, you know, now we have the individual sentences in that list, and we can iterate through it. Does this make sense, guys? Any questions? No? All right. So let's see. Now let's think, I guess I'm gonna give you a little fun exercise, right? So a little fun exercise to think of what you can do. Let's try to load. So the common theme has been to load everything into tensors, right? That has been our theme so far, at least. We loaded our wine, right? Wine Q from NumPy to wine Q torch, right? And then we had a tensor for the wine, a tensor for the images. So why not a tensor for the text, right? How do we store it? So we have to think a little bit about, you know, some kind of encoding scheme. That's the problem. We need some kind of an encoding scheme. So let's create, what do we want to do? All right, let's do this. I'm going to assign this as a homework for you guys to have a little bit of fun here. I'll give you some code, okay? I'll give you some code that you should be able to solve the rest, all right? What do you have to do? So this will be a homework due a week from today, okay? Just one problem. Load this data into a tensor, okay? To show how you do it. So let's I'm not going to solve the whole thing, but let's think about it. I need a, and I'll give you a hint. This, let's say we're going to call this the bag of words approach. With the bag of words approach, you have to identify the vocabulary in your text, So in our case, it would be the vocabulary used in the Jane Austen book, for instance. However, I can even make it simpler. Grab 1,000 words from Jane Austen. Which ones would you grab? Let's see if you could answer that question. Which words of the Jane Austen book would you grab? The most frequently used. Very good. But at the same time, do not use words like the, right, which are called stop words. Does that make sense? So filter out stop words. You can, that can be done with one line of code. Just find the library for it, filter it out. So filter out bag of words approach, and then find, let's say, the 1,000. You can do whatever you want, really. Could be 10,000. You're only limited by one thing, and that's your RAM memory. Okay, that's it. Remember, you're not building a model. I'm not asking you. I'm only asking you to build the tensor. Okay? Pick the 1,000 most frequent words, and then you need to represent each sentence, right? And use all the sentences, not just the first 200. That was just an example, but actually use all the sentences. So how do you determine the sentences? Just through length of lines, right? That'll tell you how many sentences you have. Find the most frequent words. You can find a library, I'm sure, for that. Rank them. Get the top 1,000, 10,000. It really doesn't matter. All I care about is like your algorithm, right? So because your algorithm you can modify. Make sense? And then load it into a tensor. So I'll give you some hints. Okay, so I'll give you some hints. And this is called a bag of words approach, because once you have the 10,000 words, it's like you have a, and let me actually grab, I'll explain this a little bit more in the next lecture. I'll have something for this, but let me just quickly, I'm sure you can be able to see it. Just really quickly here. I need to draw something on the board. So I'm almost done. All right, so the bag of words approach is what I want you to do, which basically means, let me switch over to whiteboard. All right, guys, so here, from that Jane Austen book, find the top 1,000, let's say, words, right? Then for each sentence, there might be many. You can take out the length of the list. It'll tell you. And then what you're going to do is you're going to take that 1,000 list of words. So it's going to be like word one. This is like the heading, right? The heading. So each sentence, sentence 1, sentence 2, sentence 3, ... all the way to sentence n, right? Each one of those is a sample. And then you will select the top 1,000. So it's going to be 1, 2, 3, ... 1,000, for instance, right? And then what are you going to do? Every set you're going to have to grab in a loop iteratively, right? Every sentence from that Jane Austen and do what? Because it's the bag of words approach, you're going to indicate which words are present in the sentence. Do you see that? So for instance, I don't know Jane Austen, but something about a party or something like that, right? So then there's party over here, right? That's the word. Well, that word may appear in this sentence, but it doesn't appear in this one. It doesn't appear in that one, and it could appear in that one. You see that? And then what's another word in Jane Austen book? Huh? Kittens, right? Okay, so kittens over here. And so kittens is not here, but it could be here. Now, what is the problem with the bag of words approach? You're going to have a lot of zeros, right? Because The words are not going to be there for all the sentences. One good thing with the bag of words approach is to make those vectors really big, right? So 1,000 is probably not good. You'd probably want 70,000 words. You see that? To have more opportunity to have more ones in the sentence. Does that make sense? Also, that's why the frequency of the words is really important. The more frequent words, the more hits you're going to have. This method, believe it or not, was used a lot. It's more useful when you do it on a per book basis. So for instance, if instead of sentences, we were using all the books in the library, that'd be better. So you'd have more ones in the vectors. Bag of words is not very good for sentences, but it's a good exercise for you to practice creating a tensor. Does that make sense? All right, so all I will look for is the algorithm that you build. So anyway, that's what you have to do. Okay, that's what you have to do. So how would you do it? So I'll give you some like scratch code, and then you can build from there. All right, so let's switch over to the machine here. Okay, guys. So we'll wrap up with this one. So obviously you need tensor, right? So we're text, what do we call it? Bag of words. Tensor. You see that? So what should you start with? Well, torch dot zeros. So torch dot zeros, correct? Doesn't matter because, well, actually, should it be zeros or ones? Torch dot zeros or torch dot ones? Zeros, because zeros are going to be the most common thing. And really, you just have to change to ones. So you start with torch dot zeros, exactly. Then we need to know now what are the dimensions? It's a tensor to hold all the sentences. So what would be the dimensions here? You have to think about this right now. That's your job now, is think about this. Remember, representing the data. So what do you think? Every sentence, right? Yeah. So what is this? Is this the length of what? That's right, the lines, right? The number of sentences, the number of lines. So how do we get that? We actually get it from the function length, right? Would you agree? And then we plug in there just lines. That gives us the number of lines that we have in there. Do you guys see that? What about this one? That depends on what? If we go back over here to our example in the whiteboard, I do. So now you're thinking about this tensors, probably your X data, right? You're thinking about that. So it's a tensor, a two-dimensional tensor, 2D. This is length of lines, right? Length of lines, however many sentences you have. What are these? Number of words, right? Number of words, exactly. So, you know, W1 all the way to whatever you define it to be. So let's just call it N or M, sorry. Let's call it M. And you define what you want it to be. Let's say, just to give you a kind of a hint or something, I'm perfectly fine if you just use 1,000. It'll be mostly zeros, but again, it's just, but this will be a tensor itself, okay? So now I'm gonna go back to my code, and it's gonna be here, let's say 1,000, just for this, how we want it to be. So now we have a two-dimensional, so I'll write here, this is a 2D tensor. It's already in Torch, ready to go. Now you just have to feed it the information that you want. So what do we do? You can say for I comma enumerate, oops, sorry, for I line sentence. I'm actually going to use the word sentence. In enumerate, right? Something like that. And we enumerate over lines. Yeah, we enumerate over lines. So every single one of these lines now, every single one of these lines needs to be converted. So 1, 2, 3, 4 needs to be converted into that vector, or you need to modify basically the Torch zeros here. Do you see that? So what will it be? It'll be, you have to find, so Torch, so how would I do it? I would probably do for word in sentence, right? 1, 2, 3, 4. So now I can iterate through all the words in there, right? And then I need to have a list of the most frequent words. List frequent words. So you need to figure out how to get that list of frequent words from lines or from the whole Jane Austen thing. Once you have that, what are you going to do? For word in sentence. Oops. 1, 2, 3, 4. What do you do now? You look for that word in list of frequent words. Do you agree? And also, you want to know where it is in list of frequent words. That gives you the index. Once you have that index, you can fill in then your Torch 0 index. You guys see that? That's all you need. So this part I'm not going to solve for you, but I'm going to say, you know, let's say, for instance, 1, 2, 3, 4. If word in list frequent words, right? If it's in there, do what? 1, 2, 3, 4. Get that index. And that's going to be index equal like that. You see that? And then what do? Then it becomes pretty easy after that. Once you have the index, you just take bow T, right? Like this, and you're going to plug in a 1. Where? Well, the first one, so it's like this. So this one should be easy for you. What is this parameter? That one should be pretty straightforward. It's one of these letters, actually. I. Yes, I. And then this one would be index. You guys see that? Because it's the I and the index, and you're going to plug in a 1 in there to indicate that for that sentence, that word is present. Make sense? Make sense to everyone? And that's it. As I said, bag of words approach is probably not the best one. And there's a lot of libraries for it, actually, but it's a good exercise for you to practice a little bit. Okay? Is this clear, guys? Are there any questions? Nope. All right, so I will create a Brightspace link, right, on the course, and it'll just say something like, as described in class, create a tensor that can load the text data from the Jane Austen story. And then you guys can just complete it. Make sense? All right, great. All right, so let's, this is a good stopping point. If you have any questions, just come see me. We'll continue with this on next week. And you have a very, very basic homework. We are pretty much done with the very basic introduction of CSV, images and text. Next time around, because I think that completes this, a lot of it today. Next week, then, I'll do a short lecture and then we will start to get into machine modeling. All right, so now you know how to play with, think about what you know, or what I want you to practice. Tensors, have a good grasp of tensors. 2, reading data from images, text, and CSV. And because next week we're starting the meat of this, which is, okay, now build a model, okay? So that will be the which will culminate in building deep neural networks. All right, so we'll stop here for today, and I will see you guys on next week, Monday.